and do it that way.
Are you doing dialogue APL or APL2?
APL2.
I don't know how that goes now with not IBMs anymore.
Right. Okay. Okay, we got a couple more minutes, I guess.
Two.
Okay, thank you, Ron. Precise as always. So is Adam not coming, Andre, or?
He's here.
He's here. Oh, I don't. Oh.
You've got 7 people now.
Okay. Yeah. All right. I get it. So the pictures are stacked. I didn't realize.
Yeah, I kind of dragged the screen, the part with pictures, over to the left and make the notes that David Selby has shared smaller so I can see everybody here.
Ah, that could be a plan.
Adam,
Yeah.
you were asking question about the logo. Could you see that?
I can see that, yeah.
That was the logo of APL in the 70s at least.
Yeah, I'm trying to figure out exactly which year that was.
Oh, this one was a gift by Dunbar, probably 78, 79, something like that.
Exactly.
But the sticker, we had a lot of sticker, green and red sticker.
And I want to know, when was the first time that somebody made this practical pun of using an apple for APL? Which year?
Huh.
76, 77, 78? When was the first time?
I don't know who made it the first time.
So maybe I'll figure it out one day. Because I'm curious what came first, the Apple for APL or the Apple for Apple computers. Anyway, that's not the subject for this hour here. Welcome to the APL Campfire. I'm very excited to have David Selby here, who is remarkable not just for what he does and has done at IBM, but also for having had a lot of influence on the actual development implementation of the original APL for PC at IBM, and also APL2. Since he has clearly prepared himself here, without further ado, to blow us away. And you might want to tell the people who are here live whether you want questions in the middle or whether we should take questions at the end.
I imagine I'll probably get abuse rather than questions. No, in this set, having worked with them for so long. But I was planning to take questions at the end.
Okay. So go for it.
Oh, okay. I will go for it, as you say. So, so what I've done is I've divided the talk up into kind of sections, and hopefully I won't run. I haven't really timed it out precisely, so we'll just have to see where it goes. But I seem to have got my esteemed colleagues here as well, so it's an unexpected pleasure.
Don't worry about the timing. I'd rather you say too much than too little.
All right. Okay. All right. Well, we'll see how it goes. So what I thought I'd do is I'd start with my journey to being an APL implementer. So I started at IBM Haven in 1977, but actually I'd already had my first day was actually in 1975, when I had 2 weeks work experience there when I was still at school. And then in 1976, I applied for an apprenticeship after I finished school. And unfortunately, I got to the penultimate round of interviews and didn't get the job. So I was really disappointed because I'd sort of kind of really wanted to go to IBM, work for IBM, because it was a really it was an exciting place to work in that time. So so I ended up calling, and this may sound ridiculous, but I ended up calling up the plant manager at Havant, and I forget on what pretext, but anyway, I ended up having it, him inviting me in, and what I didn't know at the time was that he had a big thing about trying to encourage young people into IT. And so I was sort of hit the right spot, as it were. And so he invited me in. We chatted for half an hour, I forget what it was. And the upshot was that I ended up with to being in 1976 a summer intern, and I worked in the procurement department there for a chap called Jeff Maidment. And anyway, at the end, I had a great time, and I really enjoyed working, and it was definitely the right place for me. And so I ended up going from there. That at the end of that time, I went back to school because I was actually pretty useless at passing exams. Now I still probably am. But anyway, so with that, I went back to school. I got some more exams done, and then I ended up with working for a vendor which I'd come across when I was in procurement, who, what they did was they made the frames for the mainframe computers that they were building in Havant. And the frame is just a steel, a tubulous or a square steel frame on which the motherboard is sort of bolted onto, and all the electronics were sort of bolted into that thing. Anyway, the upshot was that they also made armaments as well. So they made bomb casings as well as these frames. And I was in procurement there again, and I had some time in procurement there. And then eventually a job came up at IBM, and I applied for it. Much to my luck, Jeff Maidment, who'd been my manager in my summer job, had moved into HR, and he spent, I was really nervous, and he spent a load of time. I remember him buying me a cup of coffee and taking me into this room and chatting to me for a while. And then I went and talked to the hiring manager, who was Roland Hollick, and Roland hired me. And I turned up my first day, and the first job I had to do, they gave me a huge deck of punch cards, and I had to sort them. And so I sorted so I was there in front of this big old card sorter, and I spent the day sorting punch cards. And it wasn't actually a lost cause, because what it turned out was that some years later I was continually trying to speed up the APL interpreter, and one of the things that was slow was grade, and so I ended up implementing a radix sort in the interpreter. And of course, the card punch machine is the mechanical epitome of the radix sort. So it was kind of useful information. And then from there, after that job, I moved on a little bit later back to procurement again, and they were using APLSV, which was the internal timeshare system, which was in most of the sites at that time, and they used it to help the buyers with all the admin and processes they did for various things. And there was a youngest guy there who did APL, who did most of the coding in APL. And I was intrigued by what was going on, and I was just intrigued by APL, period. And anyway, he ended up, I asked him if he'd teach me APL, and he refused, which annoyed me intensely at the time. And after a while, I worked out how to dump a workspace, and so I ended up dumping his workspaces. and onto paper, and I took them home, and I sat down and kind of worked out how it worked and everything, and it was kind of interesting, and then I started coding myself in APL, and I kind of got better at it, and I told my manager that I wanted to be a programmer. And the only way you got into IT in those days was that you had to pass a DPAP test, a DPAP test, which is data processing aptitude test. And of course, being it was some sort of exam, I was absolutely useless at it. And I think I failed it. Well, I don't know how many times I failed it, because he basically snuck me in the back door multiple times trying to get this test done so I could get a job in IT. But I never passed it, and we gave up, I think, after umpteen attempts. And it was probably the best thing that could have happened to me, to be honest with you, but for other reasons. But anyway, so then I went on, I wrote this APL system, which essentially controlled the substrates production line. And it allowed engineers to track lots through the production line, and did all sorts of things. And the system, we ended up deploying it in France at Corbeil-Essonnes, and Timex, of all places, in Dundee. Yes, it was Timex, the same people who made the watches, and they were an outsourced vendor for IBM at that time, making these things. I remember going to Dundee and getting a tour around the watch production line, which was kind of fascinating. And let me see if I can show you. There we go. So that's what a substrate looks like. It's essentially your piece of silicon chip is mounted in the middle of it, and you get all these gold pins all around the outside. And then if we flipped it over, you'd find that there was a electronics pattern about how it directs the electricity from one of these pins to one of these chip legs. And so that was the substrate that they were producing there. So they weren't actually producing the silicon wafers. That was done in another place. They were producing these things to mount them on. But the process actually is very similar. One of my beefs, so when I had this system running, it became quite large, and I had about, I want to say, a third to 2/3 of the APLSV system was working my code. But one of the things that annoyed me intensely was that although it was running my code, the time shifting in the supervisor of APLSV wasn't actually that good. So if you wrote a really crappy APL code, you could end up hogging all of the machine resources. And I complained so much to the IT person that was running the APLSV system, and they wouldn't do anything. So one day I got so mad that if you go into the sort of main machine room, you have these huge printers there at that time, and the printers made a terrible noise. They go sort of like chunk, 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 like that all the time, and so I rigged it so you could program directly to these printers through APL, and so I rigged it so that the printer, instead of going chunk, 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 went chunk. And then it waited for a few minutes, and then it went chunk, and then chunk. And the operator got really panicked about this, which is sort of what I was hoping, and got onto the IT person and said, why are our printers sort of slowly messed up? And he had a look at the jobs and saw the jobs that were coming from me or came from me. And he got on the phone to me, and I said, look, that's what I've done to your printers in there. I said, now will you do something about these people who can't write APL? And he said, anyway, he still wouldn't, it was sort of still a bit of a waste, but it was kind of amusing at the time. But anyway, I sort of after the fact thought it would be kind of nice if I ever had a chance to write an APL interpreter again, that it would be good to write one which was totally unforgiving. If you wrote really bad code, it would run really, really slowly. So in that way, it might teach you to write better code. And anyway, so then I found I was really interested about APLSV. So I found out that there was like an admin level. So it was like a super user in Linux that they coded into this APLSV system for doing administration and such like. And I thought, like, it would be kind of fun if I was, or kind of useful if I was this admin. I had an admin privileged account rather than a regular account. So I sort of hacked into APLSV and the way you privileged your account once you had the privilege token, as it were, was through IBeams, or you did all the interactions undercover. It's just sort of fairly IBM standard. The IBeam is used as a way of getting in, backdooring into the system. And you used to, and 19 IBeam 1, I remember, was the way in which you privileged your account in APLSV. But you had to do something else so that you were able to issue that command, because if you just issued that command on its own, you'd get syntax error. But if you were in the right state, then it would actually just accept it, and it would just be a normal function. Anyway, I was messing about on the system about, I must have been about 6, 7 or 8 or 9. It was late in the evening anyway. And so I issued this command, IBeam command, which I thought was going to get me privileged or get me to be able to issue this 19 IBeam 1. And the system just locked up and it just went cold. And I thought, at the time, I didn't really think too much about it because it was late in the evening, and I thought, oh, it probably, they start running batch jobs and they shut off the APL system because they were running batch and all the rest of it. So I just shut the terminal off, packed up, and went home. 2 weeks later, I get dragged into my manager's office, and the IT person's there. And anyway, they were really mad at me, and apparently they sort of sorted through the dumps, and they worked out the people that were honest at the time, and then they sort of, I was one of the people, and anyway they kind of didn't know for sure, but they thought that it was me that would mess the system up. And anyway, they were, as I say, they were pretty mad, and I thought I was going to get fired, and I was and I remember I was friendly with Dick Dunbar at that time, and I was talking to Dick, and I told him what had happened, and I said, they're going to fire me, Dick, and he said, no, he said, they're not going to fire you. He said, it'll be way too embarrassing. He said, don't worry about it. And he said, if you need to know anything like that in the future, then just ask me and I'll tell you. And sure enough, that was the start of a great relationship with Dick, and he was absolutely fantastic. I can't really, definitely one of my all-time great mentors through my APL career, and a brilliant guy. And then from there, I went on to do microcode support, and working on banking controllers, and I had to be able to, so they taught me to assemble machines, because you had to be able to do it at the customer's office, and write patches and code in machine code. So that was great. About that time, APL on the PC came out, and I remember we had a PC in the lab. Actually, we had a couple of them, and what I did was I started playing with APL there, but the thing that disappointed me was that there was none of the auxiliary processors were the same as the ones I had in APLSV. And I wanted to have like AP124 so I could control the screen the same way as I did with APLSV, so I could write applications. And so I talked my manager into letting me take one of the PCs home. And so I ended up writing AP124 and learning Intel assembler in my spare time. And I contacted Manuel at the time for sort of how to get started, and he was extremely gracious and helped me get started with the whole thing, and was absolutely fantastic for the 10 or more years that we worked together on this stuff. So So yeah, I can embarrass you now, Manuel. I've got the chair. but yeah, a great professor, a great friend, and yeah, you know, a very important person in my life. And then I still wasn't really an APL implementer at that point, but for some reason, and I forget the reason why now, but I got asked to go to Endicott in New York for a meeting. But it was about the same time as APL 83 was in Washington, and I remember again, I was obviously connected. I'd connected with Norman Thompson at that time, and so they wouldn't let me go to the APL conference, or they wouldn't pay for me to go to the APL conference, I should say. So because it wasn't really part of my job, you know, as it were, but they would let me take vacation. So I remember taking some time off, and at the end of my Endicott trip, and going to Washington, and Norman let me share his hotel room because he was paid for to go to the APL conference. So I went there, and I had a great time at the APL conference, learned huge amount, and I was, you know, I'd already was very inspired by APL, but you know, going through that experience was just unbelievable for me. And then I went to a lecture after that in the same year in the Winchester Scientific Center. I maybe before I went to Endicott, I don't remember the exact timing, but it was in '83. And I had a, it was a nice place to work because there were only 30 people working there. And there was this network of scientific centers doing research all over Europe. And this was one of them. This is the UK one. And then and Manuel was obviously working in the Madrid one. And there was other ones in Italy, in Heidelberg, and Bergen in Norway, and all over Europe, really. I was lucky enough to find out that later in the year they had an opening for a researcher, and I was really so excited by APL that what I wanted to do was take my hobby of trying to you know, make it better and everything else, and work on it full time, and sort of get paid for the job. And also I wanted to carry on collaborating with Manuel because as I say, I found him deeply inspiring. And so I was lucky enough to get a job there, and that was what sort of launched me into being an APL implementer. So I don't want to spend a lot of time on this chart, but I know, Adam, you're very interested in the implementations that were done in IBM in the past, and I know that there's been some discussion about the IBM 5100, but I basically got this slide from Manuel and about his work that he did, and so I won't talk to it a great deal. You need to get him to talk to it in depth. Both the System 7 and Series 1 are both computers that are documented well on the Wikipedia, so you can look at them there. But a couple of interesting facts were about, you know, in terms of the foundation, was that it takes around 30 man-years effort to write an APL interpreter. It did at that time, and the whole idea of implementing APL in this intermediate language was to try and reduce the porting time, which it did successfully, down to about 13 weeks. And that was a significant change. And that, you know, as I understand it from Manuel, that he decided that he would write the IL language, and which I'll look at in the next slide a little bit more. But it was the same time when Kernighan and Ritchie were defining the C language, and so he looked at it and decided that it wasn't mature enough, I guess, and so he would do something himself at that time. So as I say, I don't want to dwell on that. You can get him to talk about that stuff. I don't want to steal his thunder. But let me just talk about, because I guess I'm one of a very few people who actually coded in IL and actually wrote a compiler for it as well. But the language, if you looked at it, if I showed you a complete module, you might be fooled into thinking that you were actually looking at an APL listing rather than this language. So it was really, but you could really characterize it as being a macro assembler variant rather than a sort of high level language like C or Pascal. Because what it didn't have was any of the for and while repeat type constructs. And so you ended up with, and in itself, it was very similar to Knuth's abstract machine that he used in the art of computing. So there were pseudo registers, and there were actually some discrete memory locations as well. And the language itself, as I say, looked very much like APL. So I've put a couple of examples there. So the first line is doing a branch on condition that the offset of register P2 is equal to 23. And if it's not, then register P6 is incremented by 2. And the big advantage of this, of having APL in this sort of higher level construct rather than pure assembler for that specific platform, was that you could retarget it more easily. And you still needed to write in assembler the OS interactions that were separate to the language, but APL itself was defined through that medium. And that led, because of the work on Series 1, then that led to the first version of APL being released. And the people in Boca Raton apparently approached Manuel and his team to produce the interpreter because of the work that they'd done on the Series 1 machine. And they wanted something that would come out at the same time as the math coprocessor. So they also had Fortran as well, I believe. And it had kind of novel features like a music processor. And I also thought it was worth mentioning that Aidan's team, which again was something that wasn't well known, they were trying to write an APL based on Fortran, or in Fortran, I should say, a definition of APL written in Fortran. And the team there were Ron Frank was the manager, and Don Orth, a complete gentleman, and helped us greatly. And I'll talk about that a little bit later on with APL2. Dave Rabenhorst, who was a incredible guy. He was responsible for the APL2 test library called Big O, and I remember Alan Graham describing it as a complete bitch, I think was the way he characterized the test library. But we used it ourselves for testing our APL2 for compatibility with the mainframe, and it was very useful for that. And then there was another guy called Corey Scott who also worked for Ron Frank, and all of that team was under Aidan. So that was the team there. So I thought it was worth reflecting about how, in some ways, IL was sort of almost became our downfall in some respects. Although it was the thing that catapulted us forward, there were some things that that became less desirable about it. So the Series 1 was a 16-bit computer, and and actually the original PC was. Now, interestingly, and not a lot of people know, but at the time we could have ended up on a Motorola platform, a 6800, and what happened was that IBM went to Motorola and to Intel, and Motorola couldn't provide enough chips for what IBM wanted, so we ended up with Intel, and so that's sort of the history of where we ended up with that PC architecture. Now, the 16-bit architecture gives you a segmented address space on all these machines, and in fact, it was the same on the machines I was working on when I was doing microcode support. They were exactly the same. And the only quirk they had was that the registers were in a memory location, which made for another interesting thing. But anyway, so the other thing that was, when I characterized this as the architecture of IL, it was ostensibly cache-based because of this architecture limitation of being in a segmented domain. So we had designated areas, as it were, for the left argument, the right argument, and for the result. And ostensibly, if it didn't matter what size array you were working on, it needed to be dragged into this area and also converted. So if you were doing a integer versus a float addition, then you would copy the float into, or part of the float array into the area, into the operations area, and you would then also copy the integer array into the operations area, but you would convert it to float. So when you actually executed the operation, you had two already conformed floating point arrays, rather than having code to do integer load and then integer load to float, do the operation, and then store the result. And of course, that when you start moving data around, that's an area where you start getting penalized. And I've worked on some very large data systems, and the current system I work on is a 6 petabyte database, and we can't even back the system up because it's so big. So it's an interesting. It gives you some interesting dynamics, but this is this gives you the same idea on a smaller scale. So that was sort of one of the hang-ups, and the second thing was, so I ended up writing the compiler for targeting IL to RISC assembler for the RS6000, but the problem was that the research organization in IBM were putting all the smarts into a C compiler at the time, and that's where all the gains were, because they were doing lots of clever things with register coloring and everything else, and I couldn't mimic that within the code we were doing. I could do things. So one of the things on the RS6000 was that you could overlay instructions. So you could process the compare before the branch. I don't want to really go into detail about it, but in the interest of time, but it was slightly weird, but there were lots of other things you could do to optimize, and I couldn't do those because I just didn't have enough time to do it. So we were kind of losing out on that, and whereas people like your company, Adam, Dyadic Systems, John Scholes had the luxury that they defined the interpreter in C, and so even though they had a very painful start with the different C compilers being different, they were already on the right road, where the only way we could move forward was essentially by rewriting the interpreter in C, and there was no appetite to do that, because it was very. I'll talk a bit about what actually happened, but it was a very painful thing to happen. And then the last thing was that Ron and I were really tasked with porting to OS2, and OS2 was a nightmare. It kept changing. The API kept changing on us. The actual operating system was unstable, and in the end, I think it was really. I think it's no secret that it was actually a bit of a disaster for IBM as well. As a product. So that was another thing that kind of caused a lot of angst in our sort of APL community. So that's all I really want to say about IL. Let me move on to another subject dear to my heart, and that was the IBM APL community. And ostensibly, I think this was one of the things that was absolutely fundamental, because what a lot of people outside of IBM don't realize is that IBM ostensibly was running on APL. I mean, literally running on APL as a corporation in every area. And we had this concept, I think it's been mentioned before, but we had this intertechnical liaison group, and we were one of the few communities that, as a software community, had our own ITL, and that was really thanks to Ray Polivka and John McGrew and a lovely lady called Beth Rush-Tibbetts, who also organised the meetings as well.
What is an ITL?
Sorry?
What is an ITL?
Intertechnical liaison.
Intertechnical. Okay.
And essentially they were meetings that were held in different IBM locations, and everybody came together in that location to talk about their APLs, concerns, and everything else. And it was really it was so important, this opportunity for people to mix and cross-fertilize, talk about what they were doing, and of course it was great because it was internal. It meant that there were no hang-ups. If we had the meeting externally, then we'd had to have the lawyers look at what we were going to say, and and so on and so forth. But we didn't need to do that. We just got together and we talked about it, and we went out for dinner, and it was really, lots of things got exchanged, and it was really very, very helpful. The other thing that was also around at that time was John McGrew had published this journal, I guess is the best way to describe it. It was just a fantastic piece of work that called the Jot Times, and it was informative. It was exceptionally professionally produced, and the other thing that was also nice about it was that it was also a work of art, because it had cartoons in it, and it was just brilliant. And so that was another piece of the most important part of this whole thing. The other thing that happened was I remember that I had to talk in front of Aidan the first time in Hursley, which was I think I was actually presenting AP124, and Dick Dunbar had come over for the meeting, and he was staying in a village near me, and I picked him up in the morning and drove him into Hursley. And I must have been really, really nervous, because he said to me at one point, I remember we were driving in, he said, what's your problem? and I said, well, I've got to give this talk this morning, and it's going to be, I'm sort of very nervous about doing this. And I said, it's going to be, there's like, the auditorium takes a couple of hundred people, and I was, it's probably the first time I talked to an audience that size, and I knew that the front row, or maybe the front row, but the people in the front would be, like Aidan Falcoff and Ray Polivka and all the rest of it, and I was just bricking it, basically. It was terrible. Anyway, he said to me, so Dick said to me, he's trying to calm me down, I guess, and he said, look, can anybody ask you a question you can't answer? And I said, well, he said, well, did you do the work? And I said, well, yes, of course I did. And he said, what? He said, can they ask you a question you won't answer? And I said, well, I guess not. He said, so what are you worried about? And anyway, so anyway, I stood up and did my talk in the morning there. And at the end of my talk, and of course, Aidan was sat in the front row, which was really right in front of the lectern, which was really intimidating. But I got through it and I was fine. And at the end, Aidan came up to me unprompted and said to me, "What a great bit of work you've done. I'm really pleased and thank you very much." It was, I mean, you know, it was so, I can't tell you how uplifting that was. And as I say, it remains with me to this day, you know, fantastic. Anyway, I still get nervous when I talk, so it's probably anyway, there you go. So the other things that were happening, Adam, I think again that you probably again wouldn't be aware of is that that the chip line in Burlington, where they were actually producing the silicon wafers, was all running on APL, and there was a couple of guys that were in charge of that, and there was Ken Fordyce and Gary Sullivan, who were great characters, and they did all the APL coding there and all of the logistics and everything else. All of the disk testing, they were coming up with new types of hard disks, and they did that in Hursley, in Rochester, New York, and in San Jose. And I know that Curtis was also involved in part of that. And all of the testing, all the test cells where they tested this stuff were machines with APL on them that were doing the tests, were administering the tests, gathering statistics, and making, you know, random tests and everything. And so and there were a couple of guys in Hursley that were involved in that. One was Vince Thomas, who I ended up sharing an office with when I was writing the machine learning algorithms for after I finished with APL. And then there was another chap who Ron and I both know well, who unfortunately was taken with COVID, but a chap called Sid Chapman, and they were the, you know, quite prime movers in that area. Jack Rudd was another interesting man, for me at least. He worked in the federal division, which was the one that sort of did all the work for the US government. And what Jack had was a workspace where he tracked all of the satellites and space junk for the US government. And that was all written in APL. And that was a fantastic application. I think he did present it at one of the SIG APL conferences as well. But we knew about it he presented it at the APL ITL long before it was allowed to be presented externally.
Which year is this approximately?
I would say it's early 90s. Dick Dunbar, you've heard him mentioned so many times. He was instrumental to this whole movement. You know, we were transitioning from a mainframe environment into a workstation environment, and a lot of the company's mentality was still glued to the mainframe mentality. But Mike Cowlishaw, who interesting enough, also worked in the Winchester Scientific Centre when I joined, but then went off to Oxford to work with the Oxford English Dictionary. He wrote this programming language for the mainframe called Rex, and he also came up with this idea of having this conferencing disk, which was used heavily internally, and it was kind of like WordPress is today. I think it's probably the easiest parallel, but it allowed you to. It had forums, and it had a way, and you could also release software on there as well. So you could put software up there and administer it, and that was essentially the vehicle we used internally to work with all our users, so they could put bugs up on there on the forum, and we could answer them and look at them and everything else. And Dick ran that system, and administered it for us, set it up, set up Mike's code, and that was absolutely fundamental to the way in which we operated internally in terms of that. The other thing I'd also say is that I also found that the community itself was phenomenal. I seldom stayed in a hotel room in all my travels when I was doing APL. I was John and Bridget McGrew. I stayed with them on some occasions. I stayed whenever I was in California. I stayed with Dick Dunbar. He lived in Palo Alto, and if we have time, I'll tell you a funny story about that. And there was John and Marianne Mizell. I stayed with them as well, and on the East Coast. But yeah, phenomenal community. Oh, and of course the inevitable Phil Smith, who I worked with as well, and Phil, I used to stay with Phil as well, and he was an incredible host, an incredible character as well.
Thanks.
Oh, Phil! Hey.
I didn't want to break in, but you know, it seems like we're all getting older. I don't know.
You are. Yeah. But yeah, well, there you go. See, now I'm really deeply embarrassed because I said, like, Manuel showed up, Ron showed up, and I'm like, I can't say anything about anybody. And I thought, well, Phil's not here, so I could say something about him. Great to see you, Phil.
Great to see you, buddy.
Okay, so let's talk about so that kind of, I think that was the community was fundamental and important. So let me talk about APL PC version 2. So I said I got this job in the Scientific Center because I wanted to make the released version better. Because that was kind of my quest at that time. So I got the job to do it, and I really characterize APL in IBM on the workstation as a cottage industry, which I think is something that English people or British people will understand as a term, but perhaps not everybody in America would. But ostensibly, it's we weren't particularly mainstream. Let's put it that way. A lot of people think IBM this huge monolith and unlimited funds and unlimited resources, staff, and everything else, and that just wasn't the case. It was so essentially I got the job. There was no Boca Raton had got what they wanted, which was a piece of software to announce the coprocessor with, which was their goal. There wasn't any plan to put out another version of APL beyond that at that time. And so I guess really, me making my mind up that we were going to do that was partly why it happened. I don't know. As I say, it was really hard. And I kind of joke really, because I remember watching a Bond film not so long ago, I guess all the competitors thought that IBM was had huge amounts of resource and everything else that we were plowing into APL and everything else, and the reality was just the opposite. It was happening because some people in IBM wanted it to happen, not because the corporation was sort of wanting it to happen. I remember that in the Bond film, the guy was saying something like, "Oh, we thought we thought you were MI5 or MI6 were watching us and all the rest of it." And he said, "And the reality is you don't know anything about us. You don't even know we exist." And I sort of thought about that, and it seemed like huge parallels, because I can imagine somebody dyadic systems or IP Sharp, thinking that, you know, they were competing with this huge monolith, or SDSC, I should say. You know, and the reality was it was three guys that had decided we were going to do this, and then that was it, really, you know. And so I needed someone to do. You see, I knew I could do coding, but I couldn't do testing, and I couldn't do documentation. I still can't really. And Ron was another legend in the APL world. He produced this thing called Apl Up, which was the Apl Utility Processor, and essentially it was all the tools you could possibly need, and he packaged them up so that they were called into the workspace so that you didn't get any name collisions. So things that would allow you to list the workspace out, and it just went on, and you know, Ron, I don't, you know, if Ron, you want to know about that, ask Ron. It's you know, but it was a fantastic tool, and as I say, Ron was absolute legend in APL coding and everything else. And so what I did was I persuaded my boss, who'd hired me into the scientific center, that we needed to hire Ron. And unfortunately, Ron was also up for it, which was brilliant. And so Ron joined me in the scientific center to do the stuff I couldn't do, and he was phenomenal at it. And what we ended up doing was we improved the first version of APL, and we made it more stable. And I think you know, Ron had made it so much better documented, and we introduced many more auxiliary processors and more workspace examples and such like. We released an internal version in 1984 through the IBM APL conference disk internally, and at the same time, the Japanese were also collaborating with Manuel, and they were releasing versions into the Japanese marketplace, and they essentially were following along the same thing, but their versions were obviously capable of having variable names that were written in Japanese, and function names, obviously. So they modified the interpreter so that it would handle that. And in fact, I went to Fukushima I went to Tokyo Scientific Center, and I remember being taken to Fukushima on the bullet train at the time by the lead there, Ude-san, and we went to a school there, and they were teaching what the Americans refer to as high school kids APL, and they gave me the textbook. There we go, which they were using to teach the children APL for their math classes, and it's a phenomenal work of art. I don't know whether it's probably too small to see here, but you know, I can read the APL fine, but the Japanese is a bit eludes me. Unlike Manuel, who speaks 7 different languages, one of which is Japanese. So as I say, man brain size of planet. But there we go. So another funny story was that Ron had just got together with his girlfriend Jean at the time, and every Friday, Ron used to print the manual out, and then he'd get on the train and proofread the manual as he was traveling to meet his girlfriend, his now wife, and so that was how we got the manual proofread, was by doing that to it, which and it ended up phenomenal. One of the things we wanted to do was we wanted to make APL more accessible, but equally we recognized that if you were serious about APL, then you would invest in the coprocessor the machine. But we also wanted to be able to emulate it, so you could take APL to any machine and run it there. And what we went for was a slightly novel approach to running it, and we ended up with we didn't go for a statically linked module, so we didn't have two versions, one with the coprocessor and one without. What we did was we worked out that for every instruction that you issued to the coprocessor, you also issued what they called a wait instruction, so that would then synchronize with the integer processor. And so what we did was we put an interrupt-driven routine into the system if we detected there was no coprocessor, and it basically sat there, and it just kept checking to see whether or not the main APL process was stuck on a wait instruction, and if it was, we patched it to the emulator, and that was how we made it do emulation, which meant it was slower on the first pass. It was slower overall, but it would always work. Except I get a phone call from Aidan Falkoff one day, sometime after we'd released the system, and he said, "David, I'm having a problem." He said, "They're about to release this box called the PC Junior, and APL doesn't seem to want to run on it." And I said, "Oh, well, that's a nuisance." So I said to him, "Well, can you send one over?" So he packaged the machine up and all the manuals and sent it over to me. And it turned out, when I got the schematics out, because fortunately, as I say, when I was microcode engineer, I got trained on how to do all the electronic stuff. So I read through the schematics, and what they'd done is that because there was no slot to put a coprocessor in it, they'd actually removed a resistor off the board, which let this wait instruction actually wait. And so what I did was I ended up taking a 4.7 kilo ohm resistor, and I soldered it onto over the processor. So I soldered one leg onto VCC and the other one onto the leg of the processor, which was needed for this wait instruction. And then the APL ran. And I called up Aidan and I said, "Well, I fixed it for you." And he said, "Oh, that's great." He said, "What did you do?" And I said, "Well, I soldered a 4.7 kilo ohm resistor onto the board, and it's now working." And so that was how we got around that one. But it wasn't a particularly practical fix, but there we go. So sent him back. So that was the kind of curious problem with that one. Printing manuals was really a real problem, because printing APL characters was even though IBM was one of the biggest printers in the world, they struggled with printing APL characters. And I remember on one occasion, I ended up with all of the release materials, and I must have been for one of the US versions. And I remember getting on a plane with a suitcase full of all the stuff, all the master documents that Ron had set up. And I'd taken them to New Jersey, and I think John McGrew came as well, or met me at the airport, and we ended up going to somewhere in New Jersey, and we spent nearly a whole day with this guy explaining how we wanted this thing printed. And John courteously, even though it wasn't part of his job, kind of kept the process going, so that when I wasn't there. So that was brilliant.
It was APL, that was part of my job.
Oh my God! Now I get in real trouble. So yeah, that was another funny event. Thank you for that, John. As I say, I'll embarrass Ron because he did basically he did everything I couldn't do, and it was and we ended up making he ended up making keycaps for all of the keyboards, all the European keyboards. At that time, you could pop the keys. You can still buy, I've noticed, the keyboards where you can plop the caps off and you can pop keycaps on. We printed had all the keycaps printed for all the European keyboards. And the interpreter also recognized those as well. So, you know, we had proper national language support. And I talked about the education. I remember Phil going to Aspen with you to a teachers conference. And I think you also tried to get me to shoot that day as well, or that weekend at one of your buddies' ranches, which was another interesting experience that I'll never forget. But I remember going to the teachers conference there, and we explained APL to them, and I remember one lady has said that it was way ahead of where they were even then, and so we came away a little bit disappointed there. One of the real challenges was, as I said, there was huge internal APL community, but getting APL out the door was a real problem, because IBM is really set up for mainframe products, and you had the most awful process to be able to release a mainframe product. You had to have a planner, you had to have, you basically had loads of paperwork to do, and it was just wow, it was a process, and I had a lot of trouble because it was a PC product as well, trying to find somebody. Anyway, I finally found this guy in Basingstoke of all places, which I know is the same place where Dyadic Systems are based, or was based at that time. There was an IBM location up there which looked after the PC for Europe, and I found this guy called Len Goddard, and he was willing to help us release the product, because I was able to convince him that we had everything done properly and ready, and showed him, all the great stuff that Ron had done, and it was absolutely fantastic. And he helped us through the process, and we got the product out in Europe, much to the annoyance of our American colleagues. So eventually it came out in the US as well. So that was the PC product, and then we wanted so the three of us really wanted to do APL2, because that's where it was at. We were really inspired by APL2 and all the stuff that was going on there. And the thing you have to understand is that there was no plan for the three of us to continue from APL PC version 2 to APL2. And somehow I managed to get myself over to Santa Teresa, because the only way I could make it happen was for Jim Brown to bless it. And so I remember going to Santa Teresa, and I literally sat outside Jim Brown's door for 2 days. I think Dunbar put me up for the week, or however long I was there. And I drove to Santa Teresa every day to the lab there. And I sat outside Jim Brown's office and finally persuaded him that the three of us could do APL2. In itself, it was a challenge, because the mainframe product was just over 1 megabyte of assembly or executable code. And we only had a 640K address space on the PC. So that was the real challenge. We had to get executable code and the workspace in that address area. It was a real challenge. Anyway, we finally Jim quiesced, and we were allowed to do it. So I came home and we were allowed to get on with it. And part of that was that Jim sent all of the source code to Manuel, which was great. So I remember this really weird meeting we all had in Madrid. So Jim came to Madrid and I came down to Madrid as well for this meeting with Manuel to discuss the internals of the interpreter. So I'm going into the room with these two guys, and I'm basically carrying an oxygen cylinder behind me because, you know, that they are, you know, these guys are way beyond my brain capacity. It's just, you know, just unbelievable characters. I mean, Jim Brown is, it says, my abiding memory of him, really, in many respects, of working with him, was he was just like Obi-Wan Kenobi in a way, because he would say very little, but it meant so much, you know. And when it came to APL, if he said something, you know, if you said, well, what about this such and such extension, and he would then give you an answer, and it was so rationalized and so logical and so well thought out, but it was expressed in such a short sentence. You know, it was an amazing, you know, it was just phenomenal at the time. Anyway, so I'm going into the room with these two guys, oxygen in hand, and we sit down, and Manuel says to Jim, I don't. So in the syntax analyzer, which is really Jim's bag, because you know, in terms of that's one of the main things that came out of his doctoral thesis. And in fact, the funny thing is that it's actually called the Jim. So and it's called the Jim because it's the jump instigation matrix, because that's the way the syntax analyzer works in mainframe APL2. Anyway, so Manuel's been looking at this and at this huge matrix, and Jim so Manuel says to Jim, he said, there's a couple of things I don't understand about this. So Jim says, oh yeah, no problem. So he says, you know, what does this mean and that mean and this mean? And then suddenly I can see the light go on in Manuel's head, which was bizarre. And he says to Jim, oh, that's fine. He said, so, and he takes his pencil and he goes through this huge array and starts scoring lines out of it, complete lines out of this thing. Like he's doing a crossword, you know, and it just, or, you know, a Sudoku, you know, it's just, you know, and Jim, and so Manuel says, well, that's redundant. This is redundant. That's redundant. This is redundant. And Jim's like, oh, it's just incredible. But he was right. It was, you know, over the years, they not ever optimized this thing or thought about it. And because in the mainframe, you know, you had the space, so it wasn't a problem. Whereas we didn't have the space, so we had to compress everything. And so suddenly it cut this thing down, and it just ended up as two or three things. It was just a seminal moment in my view, in the whole thing. And as I say, it was incredible to see Jim so shocked. But anyway, so we also ported, so that was there. So we ported APL PC16 to a 32-bit interpreter, and one of the problems I had was that the 32-bit standards were all changing. So there was a couple of guys in, I want to say in Oregon or Illinois somewhere, that had come up with this Firelap DOS extender, and some of the compilers had picked that up as the way to go to 32-bit to a flat address space, because essentially what you had to do was jump the microprocessor into a different state and then be able to drop back down again to run 16-bit code. So it was a little bit complicated. And so we had to try and second guess what was going on. And in the end, I decided that we'd write our own, because it was difficult to work out where to go. And there was also the DPM, I think DPMI spec, excuse me, was also around as well, which got you to Windows, which was a Windows original Windows spec. So anyway, we went with this with our own hand-coded approach, and Manuel and myself, we managed to code this up in about 7 weeks to get this, this 32-bit version running. We added complex number support in, and Don Orth was really helpful. Don was in Aidan's team, and he gave us a lot of tutoring on complex numbers. He gave us APL functions that we used as proofs, and that was a fantastic leg up there. I did a lot of work on improving the session manager, and because again, I thought that was really important to having a system that was usable. And one of the things we did was all the output we tagged, so you could colorize anything and everything. And that idea sort of came from Dave Rabenhorst, who wrote a sort of prototype some years before that I saw. And so we know, we had different sort of states of output and everything else. So everything got tagged properly, so you knew what you were dealing with when you got it at the session manager side. Another great guy helped us was Dick Connor, who sadly is no longer with us. It was quite a shock when he actually passed away, because he wasn't, to my mind, that old even then. But he did things like the calendar functions, and he helped us with the Fortran interface, which was something we processed through AP2. Then Al Bloom, I remember, coming to work with us. He worked for a guy called Peter Welsh, who was a fantastic statistician, and they'd come up with this workspace called GraphStat, which we ported onto the PC, onto APL2 PC that was previously was a mainframe thing. And Al came over and worked with Ron, and I actually worked with Ron most of the time, until they found the bug, and then I had to fix it. So one of the other things I did was we were in the graphics team, and the rest of the team were working on this graphics renderer called Winsome, and I got 1 year I got to go to SIGGRAPH in the States, and it was at the sort of middle of the event, they put up lots of pictures, and then for the audience to see. And in those days, people would say, oh, this took so many hours to render and all the rest of it, and for this sort of photorealistic picture that came out. And several of the pictures that were presented were done with this Winsome system. And so what I decided to do was use it to come up with the APL logo. So the globe with the road out of it, and because I wanted something that would catch people's attention and sort of make them, kind of get them interested in what might be in the box. So that was sort of where that came from. And then we had lots of auxiliary processors we shipped with APL2. I think the AP207, the graphics processor, was interesting because it was the first time that, up to that point, all the auxiliary processors have been done with sort of numbers. So you assign a number which would relate to some sort of command that you want done. Whereas with AP207, what I did was I allowed you to actually use words. So you'd say draw, and then you'd present a matrix, but you could string all of these together, or set color and all this. And a couple of guys collaborated with me on that, which was fantastic. John Baker and John Magaline. Now, interestingly, this wasn't their day job to work with me. They were wet lab engineers based in IBM Yorktown and East Fishkill, and they were fantastically helpful with that, and that was how we came up with that. Then we had Ethernet and token ring communications. And a lot of this had come because of the sort of research and lab work that APL was used for. We had an RS-232 communications protocol. We had AP190, which was a 3270 screen emulation. Another guy called Eric Fries, another IBMer, in his spare time had written an upgrade to AP440, which was released in the original version 1, which allowed you to take MIDI streams from, which was a language used by the music community at that time. And of course, Curtis with AP488 was another fantastic addition to the system, and used greatly by the people in the test labs. Prolog was written by Manuel. So this was an extension processor where you could do Prolog inferencing, logic processing. And then there were a couple of other ones that were interesting. So a chap called Stephen Deerlake worked with us, and with Nancy Wheeler, who was the queen of SQL, to do an Oracle interface for the interpreter to get to Oracle SQL. And then the other group, there was an external vendor called Interprocess Systems in Atlanta, and they produced a component file system called AFM for the interpreter as well. One of the things that I felt we needed, and you know, one of the things which was important was that I wanted APL to be more like other programming languages, rather than just this interpreter thing that you went into and did some work with. And you kind of, what I wanted was a packaged system. So I wanted to sort of link edit APL. And so I came up with this idea of ostensibly making a link editor, which was the APL packager. And so I had a stub of the interpreter that I wrote, which linked the interpreter together with the workspace, and it melded them together, and then ostensibly allowed you to just distribute the packaged application without license recourse or anything else stupid. And that way I thought that APL would kind of get more traction in the marketplace, and it would be more useful. So that was another thing we did, and that concept was later used in TryAPL, and I remember Ron Wilkes and Alan Graham collaborated and did a lot of work on packaging the APL workspace up that was used in that was packaged and then was put out and promoted by the group. And then for reference, I've put the two product numbers there. And we had, and also had the opportunity to work with some really great customers. There were people at Scottish Widows, the senior actuary there was working with us. I remember working at Morgan Stanley for a week, and John McGrew put me up, and I remember your wife Bridget was absolutely stunned because they sent a car up to Kingston for me every day to take me down to Morgan Stanley on Wall Street to work, because I said that I wanted to stay with John and Bridget and not stay in the city. And so Morgan Stanley kindly sent a car for me, a limo for me every day. But I was working with them there with some of the quants.
100 miles each way.
Yes, yeah, that was the wild one. Anyway, so APL2 led on to APL2 6000. So they gave me so IBM products at that time were given names before they were given sort of product numbers. And APL, the RTPC was named Sailboat originally, when it was under wraps. And it was developed in Austin, Texas. So I went down to Austin, Texas, had some lessons on it and some basic information about it and everything else. And they shipped one sort of undercover to me, and I had to keep it in a locked lab in our location in Winchester so I could play with it. It was relatively stable, and it was a really nice machine. And I remember that at the time, Dyadic Systems became a business partner for that, and they made a great deal of their money and supported their APL activities based on selling RTPCs. But yeah, it was a nice machine. It had a couple of quirks from an APL perspective. One, it had this folding instruction. The other thing that was also very irritating about it was on the Intel processors, if you had a floating point exception, then it would issue an interrupt. So you knew at the point that the array, that you hit some failure in the array, that you could you'd stop, and then you could issue a domain error or whatever at that point. But in their infinite wisdom, the folks who wrote the microcode for the RISC processor didn't do that, and so you had to either check on the way out that you hadn't had any exceptions, or monitor each iteration, both of which were quite slow, and they were, in fact, they were quite a drawback for APL in many respects in any implementation. But that was one of the only sort of real headaches with that machine. Otherwise, it was quite fast, and it was much better in many respects using Unix, I would say, than the previous Windows operating systems. In '87, we managed to release an internal version, which was APR2, and most of the work was done so the work transitioned from our work in the Scientific Center into Kingston. I never really remember the reason why it did, but basically it was led by this really nice guy called Mike van der Meulen, and with him was John Meisel and John McGrew, and then there was a lovely Italian guy called Mo Morelli, who was doing all the testing and everything else. And then later they were joined by this guy called Albert Fang. So that was the team that was there. And Mike and John were both fantastic Unix programmers, and they did a lot of the Linux bindings, because I'd done the interpreter translation already, and Mike did some really pioneering work on what he called the peach operator. So this was parallel each, and that was again, it was a phenomenal piece of work, and it was something that would be, what they ended up doing was they shipped out these RTPCs were all joined together, and they were made into a parallel computer. And so once you had Peach, then of course that meant that was actually quite useful. And then after that was released, Albert was sort of hamstrung on changing the IL to C. So he wrote a cross compiler, which I must admit I said was a pretty stupid idea, because, as I say, IL was a macro assembler language, and C was a higher level construct. So you're kind of compiling in the wrong direction, or translating in the wrong direction. Anyway, the upshot was that was where they went, and so they cross-compiled and got this fairly ugly C out of it, and it was sort of, it was, as I say, it was not easily recognizable. One of the big things that they missed, though, was that we had a secret weapon when we had IL, which was Manuel, because if anything went wrong, anybody called up. What people didn't realize was that Manuel carried the whole interpreter in his head, all the source code, and if anything ever went wrong, so somebody would, like Ron would get a workspace, he would track it down, and he'd say, under this condition something happens that shouldn't do. And so I'd get on the phone to Manuel, and he'd say to me, okay, go to module blah, line 52, and start single stepping from there. and I can guarantee that he was never ever wrong. So that was our secret. So once you translated it out of IL to something else, you no longer had that secret weapon. But they didn't realize that, and of course that was their loss. So that was pretty phenomenal. So they ended up getting OS2 out the door finally using that, and it was done in Santa Teresa. And then in the last, I've been talking to Nancy Wheeler, and as I understand it, so Jim Brown and Doug Ayton and her ostensibly recoded or sort of migrated the interpreter to more legible C code in the last, I guess when did I finish up? About 1996, I think was when I finished in doing APL development and went on to do machine learning algorithms, and which incidentally were all written in APL2 or prototyped in APL2 before we turned them into C code for the products, and the visualizations are all written in APL as well. So some of the original IL still remains, and one of the other things that they also didn't know was that because I was on this quest to speed the interpreter up, I'd been rewriting chunks of it in assembler, and of course it was all Intel assembler, so it was all lost in all of this IL to C translation and everything else. But I understand that Jim Brown has rewritten some of the primitives now into direct operations, and so that was sort of where we ended up there. Am I going on too much, Adam, for you, or?
It's an absolute treasure trove of information. Please don't stop.
Okay, all right. I will continue. I say.
If
So
the audience gets tired, then they're welcome to leave. But because I'm recording this, so they can check it later. But I'm not going anywhere.
okay, all right, fine. I will continue then. So I made a few. I made a few mistakes, some of which I will willingly own up to. One of them, in my quest to speed the interpreter up, was that I decided that one day that I would change the random number generator. So deal and roll. I decided in one level in the interpreter I would change them and make them go faster. So I did that, but of course, one of the things that I naively wasn't aware of was that random numbers aren't really random. And of course, as soon as we released it out, I started getting shouted at by all these people in research who were doing Monte Carlo simulation with the interpreter, because all of their runs were different and they wouldn't work anymore. So we had to back the change out. But that was definitely an oops moment. I'm also the guilty person who added Diamond to IBM APL. I wasn't the first person to do that, because my friend Dick Dunbar had already added it to an internal version of VS APL that was called APL SJR, APL San Jose Research. And so he had Diamond Separator in there, plus a lot of other interesting things that never made it to any of the products. I hadn't realized, and again, I was young, stupid, and naive, because I mean, this was in my 20s and early 30s. So one of the things I hadn't realized was that there was this culture, certainly in Aidan's team and in Jim's as well, of long, hard, slow debate about any changes to APL. And I think genuinely that was actually a really good thing. I've programmed in a lot of languages, and I can honestly say that not one has ever touched APL for being consistent and well structured, and just a joy. I mean, when I get called on to code in Python now, and I really hate it because it's pretty clear that the person who invented it didn't understand computer science and coded all their misconceptions into the language Python, and it disturbs me greatly. So anyway, but I put Diamond in, and John, and as I say, I didn't realize this sort of culture of debate and all the rest of it, because I thought it was something that we needed in there, and it was I'm not really sure now whether I made the right decision, and but equally I did it, and it got followed up and put into the mainframe as well, and John McGrew was brilliant at the time, because he was sort of honest broker, because he went to Aiden, and between them they tested carefully what we'd done, and came back to me and said, yes, it's okay, and Aiden's all right with it, and that was actually quite another seminal moment, really, because I hadn't thought about the other implication. The other thing I did was I worked with Jim Brown a lot on selective specification. I think selective specification was one of the most important additions that came into APL2. The ability to change parts of an array through an APL statement rather than through bracket indexing was again a really important thing that I still think was really fundamental to the language. And I worked a lot with Jim on the implementation process, and we prototyped and changed some of the implementation in the workstation version before it got into the mainframe. So that was kind of cool. I always wanted to do something about namespaces. As I say, Ron did this fantastic Apl up thing, which went through all sorts of gyrations to try and not clash with the workspace. And there, I didn't particularly like what the mainframe solution to the problem was, and I wish we'd done anything, because I think that was one of the shortcomings in APL, really, or APL2, was the way names clashed, and you couldn't isolate names into the workspace. And I think that was something that, if I'd stayed longer, that was something I would have liked to have spent more time with. And I also felt that a lot of the decisions were mainframe centric. Now, you have to realize that the mainframe was where the revenue was and the PC wasn't. So in some respects, it was their prerogative to drive the ship, and that was probably right and just. Although I think the flip side argument to that was that the marketplace now is all on workstations and not anymore on or in a limited number of mainframes. So I think it was and IBM's had to kind of adjust to that a bit, and they're still struggling in some ways. My other regret was having to watch all these bitter arguments about grounded versus floating arrays. I just felt that was such a loss of some brilliant people's energy. I wish that hadn't had to happen, but it did, and I think it was a shame. It was a great shame. The other thing I'd like to have done was banish auxiliary processors. I don't think they were the right medium. When you really look at them hard, all they really are, or what they ended up with, is being dynamic linked libraries. And I think we could have stepped away from that, and it could have earlier. And I think it would have been a much more cleaner way of approaching problem, rather than kind of forcing ourselves into this auxiliary processor paradigm, which was again a mainframe centric type of concept, I think, really. The other thing that I also regret is that we didn't get time on the workstation to do on a mainframe APL2. And I think John will probably tell you more about this, because he was probably instrumental in it doing it, I suspect. But it did a phenomenal job at as in default formatting arrays. And we never replicated that on the PC version. And I always thought that was a great shame, because that was something that made output so much easier to construct and look at. So that was a few reflections. Then I thought I would also capture a few what I call random odd events that kind of amused me, but may amuse you. So I worked with a guy called John Solheim, who was another APL enthusiast in research. And John was a phenomenal character, and but he was the son of he was working in IBM research, but he was actually the son of Karsten Solheim, who might mean something to you or might not. Karsten Solheim runs Karsten Manufacture, ran Karsten Manufacture until his demise in 2000. And Karsten Manufacturing are the company that manufacture Ping golf clubs. And apparently, John told me that they did a huge amount of work with APL. They did scorecards with APL for the golf runs, but they also did all the engineering, because what they were trying to do was outclass. Oh goodness, I can't remember the name of the other manufacturer they were competing with at the time. Sorry, it's gone. But ostensibly, that all the club engineering was done and physics was done using APL2PC, and that was what they were using it for. And John was so pleased about it that he said to me, I always remember him saying to me, he said, "Oh, if you're in Phoenix anytime," he said, "drop in," he said, "and I'll give you a set of clubs." And I'm like, I don't play golf. It's not interesting for me, and all the rest of it. And I've said this to some of my golfing friends. I said, he offered you a set of Ping golf clubs. My God, what did you do? Don't turn down that sort of thing. So that was kind of amusing. And John left IBM and went back to run after his father passed away. Went back and ran the company. So that was kind of an interesting story. Larry Breed was also an IBM fellow, and he worked at the Palo Alto Scientific Center. And I forget exactly why I'd got somebody. I was trying to do something with the interpreter, and Larry was kind of very good at that sort of stuff, and so they sent me to talk to Larry, and so I rang Larry and said, could I possibly come and have a chat with you about this subject? And he said, yeah. He said, but I'm very busy at the moment. He said, but if you drop by about 6:30, 7 o'clock in the evening, he said, to the scientific center, he said, I'll sit down and we can can spend the evening together and go through this stuff. And anyway, so I turned up at the scientific center, and in fact, I think it was the time you were there with me, Phil, and we were both in California, and you'd gone home and left me with this huge car you'd hired, like it was like the boat. And it was like they used on the old American cop shows, huge thing it was. And anyway, I turned up at the scientific center, and it's all dark, and I don't know what's going on, and I'm a bit worried because I was, everything else. Eventually, this guy turns up in full Scottish regalia on a bicycle, and it's Larry Breed. And I said to Larry, I said, "Oh, no, unusual attire." He said, "Oh, I've just been to my Scottish dancing class." And we sit down and we go through, and he was just brilliant. I mean, absolute brilliant teacher. I remember going through everything with him, and I got so much information that evening. It was just phenomenal. But it was just the surprise of this man turning up in full Scottish regalia. It was just rather odd. Dick Dunbar, as I said, I stayed with him a great deal, and he lived one row back from Main Street in Palo Alto. And I remember sitting outside on his porch, having a beer with him one evening, and this Japanese person came down the street, and he had one of these big telephoto cameras, and I look at Dick and like, what's going on? And he said, just wait, he said to me. And this guy walks on down the street and starts taking pictures of this garage that was further down, just a little bit down the street, could see it from the porch. And I'm like, okay, Dick, what the hell's going on? You said, well, you know what that is, don't you? And I said, no. He said, that is the Hewlett Packard garage. And and these Japanese tourists were there taking pictures of this thing. So that was kind of cool. And then another guy I ran into was Luther Woodrum, who was responsible for the grade algorithm in VSAPL. And anyway, so I was talking to Jim Brown after I met him. I said, oh, I met Luther Woodrum. I said, what a cool guy. I said, he was really fun. Oh yeah, he said, he was a lot of fun. He said, he used to, you know, he said he was the most talented janitor in research. And I said, what do you mean he was the most talented janitor in research? Well, he said, what you have to understand, he said, Luther didn't join as a research fellow, he said. He joined as a janitor into Yorktown. And he said, what happened was that, he said, you know, he said, at that time, he said, you get manuals in for whatever you were working on, he said, and then he said a month later, he said they'd release another level of the software. You get another set of manuals. So he said you turned them out and the janitor picked them up and took them away. He said, except when Luther picked them up, he took them back to the janitor's room and he sat there and read them. And basically taught himself computing by reading the manuals that everybody else was turning out. And from there, he went on and worked for Aiden, I guess, and produced the grade algorithm. But he was a lovely character, very much fun. Roger Moore also worked for Aiden Falcoff on APL 360. I sort of tried to meet all of the people that had worked on the original APL, and you know, at these conferences and places we got together and everything. And Roger was I had a beer with him and he was phenomenal. And he was so casual about everything. I said to him, I remember the conversation, we talked about doing shared variables. And I said to him, well, I said, how did you implement shared variables? Oh, and he said, I just rewrote the MCP to do that. And I was ready to fall on the floor because on a mainframe, the MCP is the master control program. And which was basically the thing that controlled all the interactions between all the units in the mainframe set of boxes. And to have somebody turn around and you know, and I'd worked on microcode, so I understood what he was talking about. And he was like, yeah, I just rewrote it so that we could get shared variables across between the systems. And he was so casual about it. But you know, this was the thing. When you met all these people, they were just incredibly talented. It was just amazing. I mean, you know, my father said to me, get the best teachers you can. That was one of his bits of advice. And all of these people, I can honestly say, were just phenomenal. Aiden, I was sat with him in a conference, and Trenchard Moore was presenting array theory. And it was pretty tough going, I can tell you. And you know, I'd sat through 2 or 3 of Trenchard Moore's lectures, and they were hard work to comprehend. You know, not because, you know, it was just my fault, really, not Trenchard's fault. It was because, you know, people that, you know, with bigger brains than me could understand him, and that was fine. And I sat there with Aiden, and I turned around to Aiden at the end of the lecture. And I remember saying to him, I said, I had real trouble following that. I said, could you explain it to me? You know, could you help me understand it? And Aiden said, I didn't effing understand it either, he said. And I don't know whether Aiden was trying to make me feel better or he genuinely didn't understand it either. So that was kind of cool. I remember APL 86. So everybody thinks, you know, again, this comes back to everybody thinks IBM's this huge monolithic organization with lots of resource and everything else. Well, I remember going to APL 86 in Manchester, and I hired this car, and Ron was supposed to go with me, and he did actually, but he went on the train because I had this car so full of computers that I'd raided from the scientific center to put on the booth, that there was no room for anything else. So I ended up driving this thing all the way to Manchester, which was, sort of a couple of hours. It's 220 miles to put it in context from Hursley up to Manchester. And I drove it all the way up there. Then I had to unload all the kit. Then I had to set the booth up, all the rest of it. And it was just like, God, I wish I was a mainframe guy, because you just roll up and you just don't have to worry about this stuff. And it was the same in Sydney, because I got to the booth in Sydney and there was no kit on it. It was just nothing. It was bare. There was nothing there. So I ended up having to get in a taxi, go out to the IBM location, try and find where this kit was supposed to be. And I remember finding it eventually, getting a couple of guys to load it up in the truck, riding with them in the truck back to the APL conference site, and then them unloading it. Then we had to set it up. And then Jim Brown arrives, and like nothing had ever happened, And it was like we had to do all this stuff beforehand. It was classic. And then Ken Iverson. I sort of thought I'd finish with Ken Iverson because I had the opportunity to meet with Ken several times and talk to him. Every time I left with the one feeling, and then he was such a gentleman. He was just such a nice man. It was just he was just an incredible guy. And I was, and John, I remember you told me a story about Ken, which was really phenomenal, and it was about these guys. So John, do you remember what you told me about Ken doing with the golf balls?
You looking for a comment from me on this?
Yeah, because you told me the
I
story.
don't recall that.
Okay, so you told me that they rang Ken up because they manufactured a load of these golf balls, but
Yes,
they did it wrong.
the typo on the type ball.
Yes, typo on the type ball. That was it.
Right.
And
Yeah.
and Ken just did them to scrap the lot, didn't he?
Yeah, we called up Ken. I discovered this typo on the type ball.
Yes.
The plus sign, they had recast the type ball because the old molds had worn out. So they got all the pieces of all the symbols. It's not all one lot. They're from different sources. So they put them all together and created a new type ball that was supposed to be the same as the previous one. But somehow the plus sign was italicized. And I was discussing that with Chuck Nurkut, the fellow I was working with at the time in Kingston. And we said, wonder what Ken Iverson would think of this. But Ken at the time, we viewed as being this completely, unreachable person, as, top of his possible category. And, it would be ridiculous to try to reach. It's like calling the CEO, at IBM about a problem like this. But I finally said, well, what would he say about this? So I called him up, expecting his secretary to answer and wanting to know what's this all about and so on. But Ken answered, and I told him about the problem, and it sounded like he was jumping up and down on his desk at that point. And I went down the next day to order some of the type balls, and the supply room guy came back in a minute after he had looked around a bit. He looked a little confused. He said, "We have them here, but we got a memo saying we're not allowed to distribute them. They've been recalled." So he fixed the problem in one day.
So there you go. So that was a fantastic Ken Iverson story for you. Okay, so I basically there's some references. If they're of any help, I'll just leave them up there for a few minutes. You can stop the video if you want them, but they're all fairly important to the whole thing that we did. And I'm basically that was what I had for you, Adam. And if anybody wants to give me any questions or comments or abuse, then I'm open for questions.
First, wow. I mean, that was way above and beyond what yeah, what I had expected. I'm so happy that you took the time. You've put in a lot of work in this presentation as well. I'm really happy we can preserve this. So bravo, absolutely.
It was kind of important to me because it was the opportunity I had to basically, in some ways, thank the people that were part of my journey.
Yeah, I can understand that. And I'll let the people who are here, many of them are your colleagues and the people that are involved here. So before they run away, there are plenty of people here that I would like to ask to come and tell the stories from their own perspective as well. Phil here, run works. Manuel left earlier, but so you get a hold of him, and Paul Jackson is here as well, right? Yeah. So if you're willing to come and tell your story, it doesn't have to be a real presentation of such a high level of visual information as what David just did, because that's incredible. But even if without any presentation, just telling some story, I would love to hear that.
David?
Yes,
David,
right.
a question on how you learned APL. Did you do it just by reading programs, or did you have access to any manuals?
I had Gilman and Rose, and I had your book, Ray.
Oh, okay.
I'm mostly interested in when you spoke about these mistakes or things regrets you had. You mentioned on that list, you mentioned the diamond, and you mentioned selective specification, but were those regrets, or it's just that it didn't go through enough of that considerate process that you thought?
So I didn't understand. I was detached in some ways from the mainframe ethos of this long sort of debate about functions and features and everything else, and basically I was doing it from a very pragmatic position. There were lots of people that wanted to migrate code onto our system, and they so they just wanted that functionality. There wasn't, and it seemed like that it was well established, and it was what I'm talking about in terms of Diamond. Yeah. But as I say, John was gracious enough to kind of facilitate the more, the longer debate process, as it were, and for me, and from that perspective, that was great. So because as I say, I was a little bit naive, I guess, really.
But in hindsight, do you consider it a mistake to add the diamond?
I have mixed feelings about it. You could write perfectly good APL without it. So it didn't really. It was sort of like an optional extra, in my view, in hindsight.
Interesting. My father got me into that debate when I was very little, as in like 1-digit years old, and I argued with him that diamond is perfectly fine. It's doesn't fit into the normal syntax, but that's just like punctuation in human language. If you have a full stop in the middle of a paragraph, it splits the paragraph into multiple sentences.
Right.
But on the other hand, APL2 never had the left function, like the identity function that returns its left argument. So that makes it hard to string things together. And then you had these kind of abuse where people would write (0) reshape.
Yes, that's true, and that did happen quite a lot. You'd see the first line, and people who would initialize a set of variables with 0 row comma 0 row in between them. And you know, you can kind of argue that one either way, I think. But so I'm not sure that you know, I'm not, as I say, from an implementation standpoint, I decided to do it. Would I do it again? Probably.
I was concerned initially about introducing diamonds only because IBM had been reluctant to use them previous to that. There had been some, I don't know what the reasons were, but there had been some feeling that, you know, we shouldn't be introducing diamond, even though other companies had done that. So when the suggestions came up about finally putting them into APL from IBM, pardon me, I figured I needed to get Aidan in on the discussions. And I met with him, and I was surprised that he was very favorable. I expected some reluctance from him, but he related it to English, and he said if we view each of the lines of code as being a sentence in English, using diamonds gives us the provision of forming a paragraph. You can have a group of sentences as one line. And I thought that's an interesting comparison, and he was all in favor of it. So I thought, absolutely, let's go for it.
That makes me proud that I, as a kid, came up with the same reasoning independently of what Aidan felt it did. So that's very nice. And so too with the selective specification, which is a very powerful thing. Regrets on that, or
No, not at all.
okay.
In fact, I don't think we went far enough with it.
Yeah, I mean, Dialog has been doing lots of that, and there's lots more that could be done.
Yeah.
There's no into it. It's exceedingly powerful things you can do that the other
Yes,
way
it
it's
is.
very
Yeah.
complicated to do.
Yeah, and I think it was, you know, and it was something that that, as I say, I rationalized with Jim Brown about how to implement. As I say, Jim's phenomenal guy to debate this stuff with. You know, once you get to his level, I think part of my problem was it took me many years to be able to get to, you know, there was people like John, and then he had John Girth as well, who was a very urbane character, who worked with him there, who they did language stuff. John, I don't know whether he is now, but he when he left IBM, he ended up with being the head of Stanford's graphics lab. But John was a very urbane character who thought a great deal about all of this linguistic constructs and syntax analysis as well. In fact, he presented a paper to one of the SIG APL conferences with a guy called Dunbar, where he talks about the syntax analysis process, and it's an extremely good read, and about the rationale that you go through to parse APL.
So I've got a couple of comments. Number one.
Are you sure you don't want your own whole hour reserved for you?
Yeah, that too.
I would love that. Please do that.
Number one, I'm still skiing all the time, and I am a licensed ski instructor. And so, Dave, anytime you want to come out, you stay here. I'll even buy your lift tickets, and you and I'll go skiing. And trust me, now I know how to teach handicapped kids to ski. So you're in good shape. Number two, I had the privilege of having dinner early on with Karsten at Solheim, and we sat the whole meal and talked about APL and how it fit into and was going to fit into his business. And I tell you, it was really exciting. Number three, I had Ken Iverson come out to Boulder and stay with me for 2 days, just so we could sit and talk and just enjoy APL together and go on walks. And it was I remember it like it was yesterday. What an absolutely unbelievable person.
I know. Yeah, he was. Yes, absolutely.
And finally, I have to tell you, I have now taken up golf, and I love golf. And I decided to build a dynamic green. The green is a quadrant that's 8 cells wide and 12 cells long. So it's an array.
Yep.
And each section of the array has a wheelbarrow inner tube, all controlled off of a set of off of an Arduino processor not yet run by APL, but I can inflate all the inner tubes at any intensity I want and make contoured greens. And all I can think about when I do it is APL. I see these wonderful shapes on the ground, and you just, you could to the real world, and this configuration it's unbelievable. So I guess my only point is today APL is every bit as exciting as the day that I learned it. I just love it. Oh, and I see a note about model trains. That's a whole nother story. I got to show you sometime.
Phil, are you up for coming
I
on in 4 weeks for the next episode?
I need some help from Dave or from all you guys, because I'm not making the progress I need to show you what I want to show you. So maybe at some point, Dave, you and I'll have to talk on a more personal level. So,
Yeah.
and unfortunately, I got to run. But gosh, it was great to see all you guys. It's what a like was pointed out. What a community.
Absolutely.
It's like all of us in our heads have this appreciation for the beauty of mathematics and the beauty of how this all comes together. And I, for my whole life, by the way, in a week I turned 80. So it's kind of like this today is just as exciting as it was 50 years ago when I learned APL. So it was
before you leave, let me comment also. I remember your presentations from the ITL conferences, and I've got to say, Adam, you've got to sign him up for a presentation here.
I'm really trying. You're hearing this. Don't worry about not having finished the projects you're working on now. Just take one episode, tell us about what you've done so far, and then we'll do another episode on what you've done since then later.
Okay. Oh, I see. A language. Oh, yeah. Oh, that was such a fun lecture, that Thoughts and Dreams lecture. But Dave, it was great to see you and hear you talk. And, we had such a fun time together, didn't we?
Oh, yeah. Yes, I will probably, I'll save the people some of the stories of the things you did to me, Phil.
All right.
David, you always...
It was great to be part of this. I won't miss another one of these.
And David, please convey our happy Mother's Day to Cynthia.
Yes, thank you, John.
Also, David, you're always welcome to come back, even if you're not the featured guest, although I imagine you probably have even more stories you could tell us, even though this was a double episode. It sounds like you have even more details you could say, but you're always welcome to come back at these meetings.
So Adam, if you see me in the UK, that's my registration plate on my car.
Yeah, well, unfortunately, I just moved, so I'm not in the UK anymore. But otherwise, I would watch out for that license plate. It's been absolutely wonderful. This our first double episode. Unexpected, but I loved it. So
as I say, I hope that's okay. I was a bit worried about the time.
It's better than okay. It's the best.
I do have a question actually. So
Yes.
Remember when you said like Python had like very few computer scientists, right? So like I appreciate APL, right, for all the beauty that it has, like the syntax, right? But and Python seems like it does everything awful about like syntax and stuff. So I'm at like how did it I don't know. I don't even know what's my question. How did APL, like, even before computing was a thing, like, how was it just invented, like, perfectly for computing without, like, it seems incredible to me how it works so well for computers, even though it invented before the computers. And then now in 2000th century, or well, 2000, right? Python has been invented, and then like it's like newer, but it's awful in every way compared to APL. So like, it just amazes me the difference.
Isn't it interesting that APL wasn't invented to be a programming language?
Yeah, exactly.
Nobody had
Yeah.
that in mind, right?
No.
So
I can't
APL
believe
hides the
how
computer from you.
Python was like, it probably, like, Python was probably even made by computer scientists to
Yeah.
help, but APL wasn't. But like, it's still even like way more beautiful.
I think that's the reason, right? Because all those computer languages that are made in order to make the computer use palatable to humans are compromising right and left. They're forcing the human to adapt to the computer. APL was never intended to be computable from the beginning. And you can even see that there are, even with the implementation, there are things in APL that are very difficult for the computer to compute. There are things that computer scientists might consider issues, like scan. Right? The definition of scan has terrible complexity. Mathematically, it makes sense. And the only reason apparently Iverson designed it the way it is because it creates some mathematical beauty when you use scans with non-commutative operands. But from implementation perspective, it's impossible to compute, right? It costs way too much. And that's probably what makes APL so great. That let the computer work harder, let the humans work easier instead.
But isn't APL like super efficient compared to Python?
For some things, I mean, it's hard to compare languages, right? But certain things are very awkward to do in APL in an efficient way. And when one result depends on the previous result, then you lose out big time in APL. Or you need the interpreter to have very, very clever algorithms to figure things out in an efficient way. For some things, it's very efficient because of being, what do people call it? They call it sympathetic to the hardware. The fact that you're storing arrays in contiguous memory, things like that.
Sympathetic to the user.
Then sure, but that might cost that might cost in complexity of it's very easy for many algorithms you come up with an APL to end up with like an ON squared algorithm, which can be expensive, and scan is an issue as well. But yeah, let the computer do the hard work. They get faster and faster. Humans don't.
Okay.
Thank you so much, everybody. Hope to see you again in 4 weeks. We'll figure out who's the guest by then.
Good.
All right, see ya.
Yeah, bring your type balls. Bye.
Thank you very much.